Have you ever been puzzled by a piece of code that just doesn't seem to work the way you expect? It can be incredibly frustrating, right? If you've ever wondered why your recursion function isn't giving you the output you anticipated, you're in the right place. Today, we're diving into the world of recursion and bit shifting to unravel this mystery. I completely understand your concern. It's disheartening when you expect a simple output like 12, but instead, you get a massive number like 393,216. You're definitely not alone in this confusion. Many programmers have faced similar situations. Let's take a closer look at the specific question at hand. One user asked, "Why is my recursion function returning 393,216 instead of 12? They expected the function to sum the results of bit shifting for the numbers 1, 2, and 3. Sound familiar? Let's break this down together. So what's happening in this recursion function? The function is designed to perform a left bit shift on the input number and recursively call itself with a decremented value. This means that instead of simply summing the shifted values, it's actually building a much larger number through repeated shifts. Let's explore this further. And stick around. By the end of this video, you'll not only understand why you're getting that unexpected output, but you'll also learn how to fix it. Trust me, you won't want to miss this. To understand why the output of the recursion function is not what the user expected, let's first break down the function step by step. When the user calls the function with the value 3, the function performs a bit shift operation on 3, which is equivalent to multiplying it by 2. Next, the function calls itself with the value 2. Again, it performs a bit shift operation resulting in 4. Then the function calls itself with the value 1, which results in 2 from the bit shift operation. Finally, when the function is called with 0, it returns 0, completing the recursion. Adding all these results together gives us a total of 12. Fun fact, did you know that recursion is often compared to Russian nesting dolls? Each function call is like a doll that contains another doll inside it, and you have to open each one to get to the smallest one. Just like with recursion, you have to resolve each call to get to the final answer. Now let's look at the answers provided by other users. This user points out that the issue arises from operator precedence in Python. Bit shifts have lower precedence than addition. To fix the recursion function, they suggest adding parentheses around the bit shift operation. The user explains that the original function was interpreted differently than intended. The parentheses ensure that the bit shift occurs before the addition, leading to the expected output. Here's a pro tip. When working with recursion, always keep track of how your function is building its output. Visualizing the process can help you understand the flow and catch any unexpected results. And there you have it. Now you understand why your recursion function returned that unexpected number. Remember, recursion can be tricky, but with practice, you'll master it. If you found this video helpful, don't forget to subscribe for more coding tips and tricks.